limits at jump discontinuities and kinks. Okay, let's again solve 18 problems. Limit as x approaches minus 3 from the positive side, from the right hand side, and the function is the floor of minus x minus 1. So since we are coming from the right hand side, we need to go a little bit higher than minus 3. So let's take it as minus of minus 2.99 minus 1, which is equal to 2.99 minus 1, which is equal to 1.99, and which is equal to, now the floor of this is 1. Now if we get closer to 3 by taking 2.999, then also it will be 1. Okay, that is the first problem. Let's look at the second problem. Limit as x approaches 1 from the right hand side of f of x, where f of x is equal to x minus 3 if x is less than 1, and x square minus 4x plus 3 when x is greater than or equal to 1. So here we are given that it is coming from the right hand side. So x approaches 1 from the right hand side implies that x is greater than 1, and it can also become equal to 1, right? So because of this, we have f of x is equal to x square minus 4x plus 3, and since it can become equal to 1, we can use direct substitution. So 1 minus 4 plus 3, which is minus 3 plus 3, which is 0. Okay. Third one, limit as x approaches 3 from the left hand side, that is from the negative side of f of x, where f of x is equal to minus 2 if x is less than 3, and minus 2x minus 2 if x is greater than or equal to 3. Now, x is approaching from the negative side, implies that x is less than 3. And if it is less than 3, it can't actually be equal to 3. Okay, so our function will be f of x is equal to minus 2. And here the x would be very, very close to 3 from the left hand side. But we have a constant. So that itself is the limit. Okay. So to write it properly, we will say limit as x approaches 3 from the minus side of f of x is equal to minus. Fourth one, limit as x approaches 0 from the negative side of the absolute value of x divided by x. Now, x approaches 0 from the negative side implies that x is less than 0. That means it is going to be negative. So, since it is negative, we will have x will be negative. So, its absolute value will be x. But here there is no absolute value in the denominator. So, it would be minus x. And if we cancel these two, this becomes minus 1. Okay. Fifth one, limit as x approaches minus 3 from the negative side of the floor of minus x plus 1. X approaches minus 3 from the negative side implies that x is less than minus 3. So let's say x would, let's take it as minus 3.01. Okay, so let's do that. Minus 3.01, and remember 1 minus is already there, plus 1. This would be floor of 3.01 plus 1, which is equal to floor of 4.01, and 4.01 is 4. Now, if we take it as minus 3.001, it will become 3.001 and 4.001. So the limit is 4. Okay, sixth one, limit as x approaches 2 from the negative side of f of x, where f of x is equal to x by 2 minus 1 when x is less than 2, and minus x minus 1 when x is greater than or equal to 2. Okay, so x approaches 2 from the negative side implies that x is less than 2. And when it is coming from the left, it can't be equal to 2. So, but the function that we would be using is f of x is equal to x by 2 minus 1. Limit as x approaches 2 from the negative side. So now what happens? We can't take equal to 2. So let's take f of from the negative side. So let's take 1.99 is equal to 1.99 by 2 minus 1, which is 0.2918 minus 1, which will be 0.005 minus. Now, if we take 1.9999, which is much more closer to 2 from the negative side, it will become minus 0.0005. So, what does this mean? It means that the limit as x approaches 2 from the negative side of f of x is equal to x by 2 minus 1 is 0. Okay. Seventh one, limit as x approaches 1 from the positive side of f of x, where f of x is equal to 3 if x is less than 1, and x square minus 6x plus 8 if x is greater than or equal to 1. Now, x approaches 1 from the positive side implies that x is greater than 1. And since it is greater than 1, based on the function given to us, it can become equal to 1. So, which means we can use direct substitution. So, limit as x approaches 1 from the positive side of f of x is equal to 1 square minus 6 times 1 plus 8, which is 1 minus 6 plus 8, which is 2 plus 1, 3. Okay. Eighth one, limit as x approaches 3 of f of x, where f of x is equal to minus x plus 1 when x is less than or equal to 3, and minus 2x plus 4 when x is greater than 3. Now, the difference between this problem and all the previous problem is here there is no direction given, that x is approaching 3 whether from left or right hand. So that means since direction is not specified, we have to try out, we have to give the limit from both the sides. So limit since, so let's take it case by case. As x approaches 3 from the negative side implies that x is less than 3, and in case of less than 3 it can actually become 3, right? So which means f of x limit as x approaches 3 from the minus side is equal to minus x plus 1, which is equal to minus 3 plus 1, which is minus 2. Now let's look at it from the other side. So as x approaches 3 from the positive side implies that x is greater than 3. And since it is greater than 3, let's take a value, and the function we will be using is minus 2x plus 4. Okay. So let's take a value which is greater than 3, but very close to it. So 3.01 plus 4, which gives us minus 6.02 plus 4 is equal to minus 2.02. So just look at this. If we had taken it much closer, so we could have taken 3.001. Then this would have become minus 2.002, 0002, 0002, 000. So it would have got closer and closer to minus 2. So which implies that left hand limit is equal to right hand limit. Here also it is approaching 2, so we can just write it as approximately minus 2, and here also it is minus 2. So since this is the case, therefore limit as x approaches 3 of f of x is equal to minus 2. Ninth one, limit as x approaches 1 of floor of minus 2x plus 1. Just like a floor function, we also have a ceiling function. So you can try out that as well. Okay, so again, there is no plus or minus, so which means if x approaches 1 from the minus side, implies that x is less than 1. So let's take a value minus 2 times 0.0999 plus 1, which is equal to minus 9 twos 18, 9 twos 18 plus 1, 19. So 1.98 plus 1, which is equal to floor of minus 0.98, and the floor of this 0.98 is minus 1. If we had taken it as 999, it would have been much more closer, but ultimately this floor function would have still made it as minus 1. Now x approaches 1 from the positive side, implies that x is greater than 1. So let's take a value which is greater than 1. So minus 2 times 1.001 plus 1, which is equal to minus 2.002 plus 1, which is equal to minus 1.002. And the floor of this is going to be minus 2. Now here you notice that this is not equal to this. So left hand limit is not equal to right hand limit. So therefore limit does not exist. Okay. Let's look at the 10th one. Limit as x approaches to of f of x, where f of x is equal to minus x by 2 when x is less than or equal to 2, and minus x square plus 2x plus minus 1 when x is greater than 2. Okay, again, there is no direction specified, so x approaches 2 from the minus side, implies that x is less than 2. Now, if it is less than 2, in that case, it can actually become 2. It can reach 2. But as far as we are concerned, in this case, the function will be minus x by. So our limit statement becomes as x approaches 2 from the negative side of f of x equal to minus x by 2 is equal to minus 2 by 2, which is minus 1. Now let's look at it from the other side, from the positive side when it approaches, which implies x is greater than 2, in which case our limit statement becomes as x approaches to the positive side of f of x equal to minus x square plus 2x minus 1. So again, let's do some substitutions. Minus 2.01 square plus 2 times 2.01 minus 1 minus this will be what 4.0401 plus 4.02 minus 1. This becomes minus 1.0201. So again here if you notice it gets closer and closer to minus 1. So here also it is minus 1, here also it is minus 1. So left hand limit is equal to right hand limit, which is equal to minus 1. Okay, let's look at the 11th one. Limit as x approaches minus 1 of f of x, where f of x is equal to minus x square minus 4x minus 3 x minus 3. This when x is less than or equal to minus 1, and this when x is greater than minus 1. Okay, again there is no direction. So when x approaches minus 1 from the negative side or from the left hand side, implies that x is less than minus 1. So here if you look at it, it can actually become equal to minus 1. So we can use direct substitution. So therefore limit as x approaches minus 1 from the minus side of f of x equal to minus x square minus 4x minus 3. Again you have to be careful. So this would be equal to minus 1 square minus 4 minus 1 minus 3, which is equal to minus 1 plus 4 minus 3, which is minus 4 plus 4, which is 0. Okay. Now x approaches minus 1 from the positive side, implies that x is greater than minus 1. Now in this case, it can't be equal to minus 1. So we have to take a value very close to it. But in this case, our limit statement becomes as x approaches minus 1 from the positive side of x minus 3 equal to from the positive side. That means minus 0.99 minus 3, which is equal to minus 3.99, which is approximately equal to minus 4. So here again, left hand limit is not equal to right hand limit. So therefore, no limit exists. 12th one, limit as x approaches 2 of x plus 2. Again, no direction specified. So as x approaches 2 from the minus side, in that case, let's take a value 1.99 plus 2, which is equal to 3.99, which is equal to 3. Now, as x approaches 2 from the positive side, that would be 2.01 plus 2, which gives us 4.01, which is equal to 4. So again, LHL not equal to RHL. So therefore, no limit. 13th one, change gears. So limit as x approaches 3 from the negative side of 2 times e to the power of 1 by x minus 3 divided by e to the power of 1 by x minus 3 plus 1. Now here 2 is a constant. So let's take 2 out. So limit as x approaches 3 of e to the power of 1 by x minus 3 by e to the power of 1 by x minus 3 plus 1. Now e itself is a constant. So which means we can write it like this. E to the power of limit as x approaches 3 from the negative side. This should not be 1, force of habit. Okay. Of 1 by x minus 3 divided by e to the power of limit as x approaches 3 from the negative side of 1 by x minus 3 plus 1, right? So which means we need to focus on this limit as x approaches 3 from the negative side of 1 by x minus. Now x approaches 3 from the negative side implies that x is less than 3. Now, if x is going to be less than 3, that means x minus 3 is going to be less than 0. That means in the denominator you will have a negative sign. So we can take it as a negative sign in the numerator itself, right? But the important thing here is that as x becomes smaller and smaller and smaller, sorry, the denominator becomes smaller and smaller and smaller. What happens? 1 by that very small denominator makes this limit go to minus infinity. Minus because of that, because it is less than 0, minus, and it goes to infinity. So our statement here will become 2 times e to the power of minus infinity divided by e to the power of minus infinity plus 1, right? Now, another interesting aspect is that e to the power of minus infinity can be written as 1 by e to the power of infinity, right? And 1 by a infinite number is equal to 0. So we can say e to the power of minus infinity is equal to 0, or basically tends to 0. So let's take it as 0. And because we want e to the power of minus infinity plus 1, let's add 1 to both the sides. So we get e to the power of minus infinity plus 1 is equal to 1. So here what happens? We end up with 2 times e to the power of minus infinity by e to the power of minus infinity plus 1 is 1. And e to the power of minus infinity is equal to 0. So the overall limit is 0. Now, 14th one, limit as x approaches 1 from the positive side of minus 3 times x minus 1th root of e by x minus 1th root of e plus 1. Again, don't get confused. It is just a different way of writing the same thing what we did previously. Minus, actually minus 3 we can take it out. So minus 3 times this limit e to the power of 1 by x minus 1, e to the power of 1 by x minus 1 plus 1, okay, which can be again written as minus 3 times e to the power of, because e is constant, so limit of as x approaches 1 from the positive side of 1 by x minus 1 divided by e to the power of limit as x approaches 1 from the positive side of 1 by x minus 1 plus 1. So which means we need to focus on this limit as x approaches 1 from the positive side of 1 by x minus 1. Now x approaches 1 from the positive side implies that x is greater than 1. Now, since this is going to be greater than 1, that means the denominator is going to be a positive value, right? And it will keep becoming smaller and smaller and smaller. So that means this would be equal to infinity, okay? So our statement will become minus 3 times e to the power of infinity by e to the power of infinity plus 1. Now, this e is constant. Constant to the power of infinity would be infinity, and adding 1 to it doesn't really matter. So 3 times e to the power of infinity by, so which means we can easily ignore it. So e to the power of infinity. These two get cancelled out and we are left with minus. So that is the limit. Okay, let's look at the 15th one. Limit as x approaches 0 from the negative side of minus absolute value of x minus 1. Okay, so from the negative side, if we are coming, let's take a value which is very close to 0 but is negative. So minus 0.001 minus 1, which will be minus absolute value of minus 1.001, which is equal to minus 1.001, which is approximately equal to minus 1. See, the more the decimal places we go to, the closer it becomes to minus 1. Okay. 16th one. Limit as x approaches 1 from the negative side of f of x, where f of x is equal to x plus 1 when x is less than or equal to 1, and minus 2x minus 2 when x is greater than 1. So x approaches 1 from the negative side implies that x is less than or equal to 1. Actually less than 1, but if you look at these conditions, it can become equal to 1. Okay, so therefore limit as x approaches 1 from the negative side of f of x is equal to, now we have to choose which of these. So that would be x plus 1. Since it can be equal to 1, we say 1 plus 1, which is 2. Okay, 17th one. Limit as x approaches minus 3 of x plus absolute value of 3x plus 9. Again, no direction is given. So which means we have to look at both the sides. So if as x approaches minus 3 from the negative side, let's take a value. So minus 3 point. For simplicity's sake, for simple calculations, let's take it as 3.01 plus absolute value of 3 times 3.01 minus plus 9, which is equal to minus 3.01 plus absolute value of minus 9.03 plus 9, which gives us minus 3.01 plus absolute value of minus 0.03. This becomes minus 3.01 plus 0.03. This would be equal to minus 2.98. So as we take more, number of decimal digits, this will get closer and closer to minus 3. So we can say approximately equal to minus 3. Now let's look at it from the other side. As x approaches minus 3 from the positive side, then what happens? So let's take minus 2.99 plus absolute value of 3 times minus 2.99 plus 9. This would give us minus 2.99 plus this would be minus 8.97 plus 9, which is equal to minus 2.99 plus 0.03, which is equal to minus 2.99 plus 0.03, which is equal to minus 2.96. So again, as we take more and more decimal places closer and closer to minus 3, we will end up closer and closer to minus 3. And here if you notice, here also it is minus 3 and here also it is minus. Okay, so therefore limit as x approaches minus 3 of x plus absolute value of 3x plus 9 is equal to minus 3. Now there is another way of Solving this without going through all these hassles, let's very briefly look at that, or rather quickly. Minus 3 of x. So we split this into two parts. So limit as x approaches minus 3 of absolute value of 3x plus 9. Now this we can directly do substitution. Plus here 3 is common, so 3 we can take it out. Limit as x approaches minus 3 of x plus 3. So minus 3 plus 3 times. Now we can again do direct substitution. Minus 3 plus 3. So minus 3 plus 3 times 0, which is equal to minus 3 plus 0, which is minus 3. We could have done it in a much simpler way. But you need to have, you need to be able to do this type of thing. So this was the 17th one. Now let's look at the 18th one. Limit as x approaches 1 from the negative side of f of x, where f of x is equal to 2x minus 5 if x is less than 1, and minus 2x minus 1 if x is greater than or equal to 1. Now x approaches 1 from the negative side implies that x is less than 1. So if it is less than 1, then it can't be equal to 1. So what we'll do is we will take this as limit as x approaches 1 from the minus side of f of x is equal to less than 1. So 2x minus 5, which is equal to, let's take a value which is very close to 1 but less. So 0.99 times 2 minus 5, which is equal to 9 twos 18, 1, 9 twos 18, 8, 1, 9 twos 18, 19, 1 minus 5. And this would give us minus 3.02, which is approximately minus. So that is limits at jump discontinuities and kinks. That's it for now. Bye.